Hello, this is a note on doing a updating the logbook or the DR plot, transcribing the logbook to a series of courses and changes recorded in the logbook to a final DR position. And the example, and we're going to do this with the StarPilot navigation program in two ways, which I'll show in a moment. And the problem we're going to do is from this book, from our workbook, lesson 5 on dead reckoning. Let's see. It's in here, right here. So this is a problem where there's a logbook entry where there's a time and log and some information, and our job is to figure out what it starts at 12 and there's 3 or 4 course changes, and what is the latitude and longitude, your DR position. And so here's that problem. Here's that problem right here that we're after. We're going to do it a couple ways, and then I've got the answer, and we'll see if we get the right answer. Okay, so that's the problem. We have to keep this thing in view somewhere. Well, let's see. Okay, so here's the StarPilot, and it comes in various, it can be for an HP calculator, a PC computer program, or the iPhone, iOS application. So we want to do DR piloting. No, actually, excuse me, that's what we want to do, but let's start with the settings and go into DR. We'll start out with our DR position, which we know. This thing may be a little bigger than it needs to be here, okay, like that. Okay, so here's our DR position, and again, those who don't know it, the StarPilot has a sort of a custom way of entering these angles. This means a 48.286 means 48 degrees 28.6 minutes, and that's that. And then the longitude and the east longitudes are, west longitudes are minus, so it's 122.462, and that's that. So that's our starting point. Then we have to decide here how we're going to do it. We can do speed, time, and distance, or we can do log readings. Let's do this one, a little bit longer method, speed, time. It's better, frankly, it's better to do log readings. Log in the ocean navigation by DR is better with a log, which sort of averages out your speed. But let's do this for speed, time, and distance. And also, this is magnetic. And all of these problems in this workbook are done with a variation of 20 degrees east. So that's plus 20. So this program here, for this step, really wants it in true best. So this we got to add 20. So the first course would be 202. That's in there, right? And then the first speed is 6.0, and that's in there right now. And the DR time, that's 12.0. So that's our starting point when we're doing the speed, time, and distance method. And that's okay. All right, now we go to the function update the DR. And let's see, what do we've got? So it's got the DR position in it, and this is the way it works. There's 2 ways we can do it. At each leg, we can have it automatically update the sort of the system DR. There's an ongoing DR that's stored in this program that is what's used for the celestial computations, so that it brings up the latest DR like you would do in the ocean. You do DR plotting, and then you need to update the DR, and then you do that for the celestial fixes and so forth. But so we can update the DR. But this one we'll do it. In fact, I'm going to get a piece of paper. Since we're going to do this 2 ways, I'm going to write down the runs on each one. Okay, so the first one is 12 o'clock. Yeah, 12 o'clock. And we don't care what the log is here. We're on course 202. That's right. We're going 6 knots. And the next time we care about the position is 1238. So this one applied to 1200. That's stored in the system. Okay, so this is this is 12. What do we want? 1238. So this is 38. Okay, that's it. Now everything's there. We just update the DR. So that's the new position right there. And we ran on the first run, we did 3.8 nautical miles, obviously in the direction we went. Okay, now I should update that because I'm going to do the next step, so I have to update that. Now then, and so you see that changed what was here in the DR. It moved this one into this one. Okay, now what happens here? At 1238 we change course to 222 plus 20, that's 242. So this is 242 here, true. Now do we change speeds? Let's see, yes, we go up to 6.5. So this changes to 6.5. So at 1238 we're changing to course 242, and we're up in our speed. And now we want to go from there up to 1312. So 1312 is the next step. 1312, like that. And there we do the next step, update the DR. So that took us up to here with a run of this time 3.68. So that means the time between these two, 38 and 38, yeah, it's about the same. Okay, so that's good. Now now we're at 1312, and here we're going to change course to 294 true. 274 plus 20, 294. And we're going to up our speed at 1312 to 7.0. 7.0. And now we're going to ask, where are we at 1430? So the speed is, no, we don't change course. 376 at 1430. We're changing. Oh yeah, we are going to change course at 1430. Okay, so I got to go to. I was thinking I'd go clear to the end here, but I can't. So I've got to go to 1430 because we changed course at 1430. Okay, so I'm at 294. I'm going 7. I got to go up to 1430. Well, let me update the DR. To be sure that was where it was before. Now I compute the new one. Okay, I lost track of my run. Okay, let's just do the last one. Okay, so now we're staying at 7, and at 1430 we change course to 205, 225, 225, and then I'm going up to 1530. And now I compute that, and I went 7 miles. That's obvious because that's going 7 miles an hour for an hour. So then I update the DR, and this is my end position. That's the result, 422, 4822, and 13. Here's the answer from the book, 13.1. Okay, so that works. I'm going to actually stop this and make another video where we do it the other way, but I don't want to lose all this time if I make a mistake on the next one. So I'm going to end this one.